So I have a question here which is saying, assume Zesco is the sole provider of electricity in Zambia. To meet the monthly demand for electricity in the country, which is which is given by the inverse demand function, P equals 1000 minus zero point 0.5 Q. The utility company has set up two electric generating facilities. Q1 kilowatts are produced at Kariba Dam and Q2 kilowatts are produced at Victoria Falls. So Q, which is the total quantity of electricity produced, equals Q1 plus Q2. The costs of producing electricity at each facility are given by C1 Q1. This is our total cost function for Kariba Dam. C2 Q2 is our total cost function for Victoria Falls, respectively. So determine the number one, the profit maximizing amounts of electricity to produce at the two facilities. Okay. So when you're dealing with questions of profit maximization occurs where marginal revenue equals marginal cost. Marginal revenue is the additional revenue that you get when you sell one more unit. Marginal cost is the additional cost that you incur when you produce one more unit. Okay. So this is how I'm going to do this question here. Say solutions. All right. So for number one here. So I'm going to say step one. Get, get total revenue function and find the marginal revenue. All right. So if you remember, colleagues, total revenue, TR, is price times quantity. All right. The price in this case here is going to be P equals 1000 minus 0 0.5 Q. And the quantity is just going to be Q by itself. Okay. So here, this method that I'm showing you is more like a shortcut method, a very simplistic way of doing this question, all right? Yes. So this expression, Q equals Q1 plus Q2, you're going to see it later in my tabulations, okay? Yes. So here, let's find our total revenue function. So Q, just leave it as it is. Don't yet substitute with Q1 and plus Q2. Okay. So we're going to say P is 1000 minus 0 0.5 Q. I'm going to multiply this with Q. 1000 times Q, that is 1000 Q. Minus 0 0.5 Q times Q, that is 0 0.5 Q squared. Okay, that is our total revenue function. I hope we're all clear with that. Remember, if you've got any questions, feel free to ask. Yes. Once you get your total revenue function, you need to get the marginal revenue. So the marginal revenue is the derivative of the total revenue function. So you're going to say marginal revenue equals dTR. What we mean here is dTR over dQ. It's just saying we are going to derive this total revenue function with respect to Q. Q is the variable we're going to be focusing on. Okay. I hope we're still conversant with their differentiation. All right. 1000 Q, this is like 1000 Q to the power 1. Remember, when you're deriving, you multiply the exponent with the number in front of the letter, which is called the coefficient. So you're going to say 1 times 1,000. You're going to get 1,000 here. Then you subtract a 1 from the exponent. So 1 minus 1, that is 0. So you have 1,000 q to the power 0. All right. And remember, anything to the power 0 is the same as 1. So we don't even need to write q to the power 0. We just write 1,000 there. All right. That's how we've derived this 1,000 q. Minus 0.5 q squared. Multiply the exponent with the coefficient, number in front of the letter. 2 times 0.5, that is 1. Subtract a 1 from the exponent. 2 minus 1, that is 1. So you get 1 q to the power 1. All right. Yes. So our marginal revenue is 1,000 minus q. Okay. You can just write it like this: 1,000 minus q. Yes. Any questions before we go to step 2? Okay. Step 2. Get the marginal costs, right? Since we're already about total cost function, okay, so you don't need to derive your total cost function, okay? If you haven't been given a total cost function, just remember the total cost is just the cost per unit multiplied by the number of units produced. Excuse me. So here we have our cost functions here, okay? So we're going to say this C1, Q1. So since these are identical cost functions, so what happens to one function is going to be the same that's going to happen to the other function. Okay, so you're going to say C1, Q1 equals 10,050 plus 5Q1 squared. Okay, so to get your marginal cost is the derivative of your cost function with respect to Q. We're deriving with respect to Q, right? So this 10,050 disappears because it doesn't got a letter, right? This 5Q1 squared, remember, multiply the exponent by the coefficient. 2 times 5, that is 10. So you're going to say 10Q1. Then you subtract a 1 from the exponent. Okay, so you have 10Q1 to the power 1. Okay, so this is our marginal cost for our first facility, Kariba Dam. Okay. Now, as I said, the cost functions are the same. So the marginal cost function for Victoria Falls, MC2, okay, meaning you're going to derive your cost function C2, Q2 with respect to Q. Okay. So when you derive this function here also, 10,050 plus 5Q2 squared, all right, we're going to get 10Q2. Okay, 10Q2 to the power 1. All right. Yes, so those are our marginal costs. Okay. Yes. Then finally, step 3. Equate marginal revenue to marginal cost to get get profit maximizing quantities. Okay. Yes. So here we're going to say the marginal revenue MR is equal to MC1 and is also equal to MC2. Okay. So here, this is we're going to have to first express our Qs in terms of either Q1 or in terms of Q2. All right. So in order to do that, first things first, let's work on our marginal cost functions here first. All right. Remember, MC1, we're saying MC1 is equal to MC2. Okay. So you're going to say 10 Q1 equals 10 Q2. Okay. So here, as I said, we can express these Q1 or Q2, okay, in terms of the other function, okay. If you want to make Q1 the subject of the formula, you can make it, or you can make Q2 the subject of the formula. So if we make Q1 the subject of the formula, we just divide both sides by 10. Okay, so Q1 equals Q2. Okay, Q1 equals Q2. So colleagues, this is where now this expression is going to come in play. This Q equals Q1 plus Q2. All right, because, so we're going to put the expression here. Q equals Q1 plus Q2. So here, we can simplify this expression and we can either substitute Q1 or Q2 in this expression. Okay, so if we say, okay, since Q1 equals Q2, okay, substitute into this function here. Okay, so let's work with Q1. Okay, as I said, it's up to you to choose which Q you want to work with. Okay, so you're going to say Q1. So remember, this Q2 is also equal to Q1. So we can substitute this Q2 with Q1. Okay, okay. So Q1 plus Q1, that gives us 2 Q1. Okay. You have to just choose which Q you want to work with. If you wanted to work with Q2, would have done the same here. You would have just said Q equals this Q1. You would have substituted it with Q2. Okay, so you'd have said Q2 plus Q2 equals 2Q2. All right. So you can work with either. So we're going to work with this one, colleagues. All right. And this, we're going to take it back into this expression here for marginal revenue equals marginal cost. We're going to use one marginal cost here. All right. So we come back to the point of profit maximization and we're going to say marginal revenue equals MC1, marginal cost 1. Marginal revenue was 1,000 minus Q equals 10 Q1. Okay. So remember, colleagues, we have got this Q equals 2Q1. So this expression, we're going to bring it in here. Okay. because we want to find first Q1. Once you've chose which Q you want to work with, then find the value of that Q. Okay, so since we've chose to work with Q1, all right, so Q, remember Q equals 2Q1. So this becomes 1000 minus 2Q1. Okay, this Q has become 2Q1 equals 10Q1. Okay, so we can find the value of Q1. So we're going to say 1000 equals 10Q1 plus this negative 2Q1 crosses over the equal sign and becomes positive 2Q1. Okay, so I'm going to say 1000 equals 10Q1 plus 2Q1, that is 12Q1. Okay, so to find the value of Q1, just divide both sides by 12. Okay, so we're going to say 1000 divided by 12, 83.3333. Okay, so Q1 equals 83.33. Okay, colleagues? Then Q2, remember, colleagues, here, Q1 equals Q2. Okay, so, and since the cost functions were identical, so even Q2 equals, so we're going to say, therefore, since Q1 equals Q2, Q2 equals 83.3 units. Okay, Q2 is also 83.3 units. Right. So the profit maximizing quantity, which we said Q equals Q1 plus Q2, is going to give us 83.33 plus 83.33. That's going to give us 166.66. 166.66. If one can round off to whole numbers, which we can say 167 units. Okay, 167 units. So that is the profit maximizing quantity. Yes. Any questions? Okay. Determine the optimal price. Okay, so the optimal price is determined by using the profit maximizing quantity. Okay, the optimal price is the best price to charge for this electricity. So remember, colleagues, P equals 1000 minus Q. And we already have Q. Q is 167. So we're going to say 1000 minus 167. Right. So 1000 minus 167, 833. So this is the price to charge to make the maximum profit, 833 kwacha. Okay, that's the optimal price, the price to charge so that you maximize profit. Okay, any questions? Okay, the utility company's profits. All right, so basically here we have to find the profit, the this maximum profit we should be talking about. All right, so we come back to first our total revenue function. Our total revenue function was 1000 q minus 0.5 q squared. Because remember, colleagues, profit equals total revenue minus total cost. Okay, so let's get our actual total revenue. So we're going to say 1000 multiplied by q, which is 167, minus 0.5 multiplied by 167 squared. So 1000 multiplied by 167, we're going to get 167,000. Then we're going to here we're going to say 167 squared. That is 27,889 multiplied by 0.5. That gives us 13,944.5. Okay, 13,944.5. Just hold on. Okay, so we're going to say 167,000 minus 13,944.5. We're going to get 153,000. 153,055 kwacha 0.5. Okay. Yes, that is the total revenue. That is the total revenue. Okay. After we got our total revenue, now we can get our total costs. All right. So we come back to our cost functions here. 10,050 plus 5q1 squared. So let's find our C1q1, C1q1, 10,050 plus 5q1 squared. Okay, so we already have q1, so we're going to say 10,050 so we say 10,050 plus 5 times q1 is 83.3. So we're going to say 83.3 squared. Okay, be careful here, colleagues. This is not just the plain q, no, it's q1. Okay, so 83.3 squared. Okay, so again, say 10,050 plus. So 83.33 squared is just the same as 167. Okay, 5 multiplied by Oh, wait, no. 83.33 squared. That is 6,943.88. Okay. 6,943.88. And then we multiply that by 5. That gives us 34,719.4. So 34,719.4 plus 10,050 gives us 44,769.4. So remember, since these are identical cost functions, so for Q2, the cost function for Victoria Falls is also going to be 44,769.4. Right? Yes. So our profit, as I said, is going to be TR minus TC, and TC breaks down to both cost functions here. So say TR minus C1 plus C2. So our total revenue 153,055.5 minus 44,769.4 plus 44,769.4. So 44,769.4 plus that plus itself, you get 89,538.8. So I'm going to say 153,055.5, 153,055.5 minus 89,538.8. We get 63,516.7. Okay, this is the maximum profit that can be made.